Welcome back to All This Math, and for this lesson, we're going to get into some factoring of expressions. And here we have a trinomial. And why is it called a trinomial? The prefix tri means three. Just like a tricycle has three wheels, this trinomial has three terms. Now, terms are separated by plus and minus signs. So you got k to the fourth minus, that means that's a term, and this is a term, minus 4k to the third plus 4k squared. Terms are separated by plus or minus signs. So this is a term, this is a term, and this is a term. The 4 and the k to the third are together as one thing, one term. The 4 and the k squared are together as one term. So this is a trinomial. Now, when we factor in or breaking an expression down into smaller parts with smaller exponents, always try to find a GCF first. Now, every expression not going to have a GCF, and that's cool. But you should always check to see if it's got a GCF, because a lot of times it's going to have a GCF. And you'll save yourself a lot of trouble and effort if you can break the problem down by pulling out a GCF or a greatest common factor first and foremost, before you try another method of factoring. Because there will be problems where you will have to do multiple methods of factoring. So first, let's look for a GCF. So first I look at all my coefficients. That's got a coefficient of 1, because if there's no number written in front of the letter or the variable, that means the coefficient is a 1. And a coefficient is just a number that's in front of the variable that tells you how many of that term you have. So how many k to the fourths do I got? I got one of them. And I don't need to write 1. I could write 1k to the fourth, but you don't need that. Like, what's understood don't need to be said, all right? So we got k to the fourth, we got 1, and then I got -4, and then I got +4. So out of 1, 4, and 4, even though it's a -4, the GCF is a 1. Because 1 is the biggest number or the greatest number that can divide evenly into all three of those numbers. All right? 1 is the biggest number. So don't get it confused with a multiple, right? And if you was looking at it thinking, well, why can't it be 2? 2 can multiply into 4, but 2 can't multiply into 1, right? Because when we factor something, factoring is like this. You looking for the number that these numbers can be divided by. Now, 1 can be divided by 1, but 4 can't be the GCF, because if you divide 1 by 4, you get a decimal or a fraction. It can't be 2, because even though you could do 4 divided by 2, 1 divided by 2 again gives you a fraction or a decimal. So the biggest number that you can divide all three of these numbers by, this invisible 1, there's -4, and there's 4 by, and you still get a whole number, is 1. So that takes care of the coefficients. Then you look at the variables. I got k to the fourth, k to the third, and k to the second. When you are trying to find the GCF of variables, basically what you do is, well, here's a shortcut way to look at it. You look for the variable that they all have in common, right? Or that shows up in every term. So this got a k in it, this got a k in it, this got a k in it. Then you look for the k that's got the smallest exponent. That's a 4, that's a 3, that's a 2. 2 is the smallest. So that means that k squared is your GCF out of your variables. So 1 is your GCF out of your coefficients. And then you put that with the k squared, which is the GCF out of your variables, and that gives you 1k squared, or 1 times k squared. And 1k squared is just k squared, right? Just k squared. So let's write that down. Let's say the GCF is k squared, all right? Now remember, if you don't understand anything about how we got that GCF, run this video back. Run it back from the top and watch it again. And listen to what happened. Let's watch what we did in terms of checking all of our coefficients and then checking all of our variables. All right? The numbers and the letters. Look what we did. All right? Because that's very important. Because that's how we get our GCF. Once you get your GCF, you're going to write it again. Right? You write it here, k squared. Then you're going to write a set of open parentheses. Now, you might be wondering, well, how wide should the parentheses be? The parentheses should be wide enough to fit 3 terms in it. Why 3 terms? Because I started out with 3 terms. If I started out with 4 terms, then my parentheses should be wide enough to fit 4 terms. Because if I start out with 4 terms, I'm going to end up with 4 terms in the parentheses. If I start out with 3 terms, I'm going to end up with 3 terms inside the parentheses. If I start out with 2 terms, I'm going to end up with 2 terms inside the parentheses. Because the steps are, when you pull out a GCF, are to first find the GCF and then divide everything by the GCF. Those are the 2 steps. Find the GCF and then divide everything by the GCF. So we already found the GCF. Now it's time to divide. So we're going to do k to the 4th divided by k to the 2nd. Now to do this, you got to know the division rule for exponents, or what some textbooks will call the division property, all right, or the quotient property, or the quotient rule. If the variables or the bases, in this case, which are k, match up, what you do is you write that variable one time, and then you will show subtraction of the exponents. This top exponent minus this bottom exponent. So you're going to have 4 minus 2, right? And then you do the math. You do the 4 minus 2, you get the 2. So you're going to have k squared, right? You take that k squared, throw it in the parentheses. Then we do the same thing with the next term. We got negative 4 k to the 3rd divided by the GCF. Remember, find the GCF, then divide everything by the GCF. So now this is a negative 4 on top. That's a coefficient. What's my coefficient on the bottom? A 1. Whenever there's no number written in front of the letter, and I'm calling it a letter instead of a variable, right? It's understood to be a 1. Negative 4 divided by 1 is negative 4. So you write your negative 4. Then you got k cubed divided by k squared. So we're going to do k, and then we're going to do 3 minus 2. It's always top minus bottom, top minus bottom, top minus bottom. When you get a little more comfortable with the division rule, you can do some tricks where sometimes you might want to do the bottom minus top. Sometimes, but not right now. So 3 minus 2 is 1. So that gives us negative 4k to the 1st power. Do I need that exponent 1? No, I don't need to write the exponent 1. Just like you don't need to write the coefficient 1. Just like you don't need to write the denominator 1, right? So we can just say equals negative 4k. You don't need to write the exponent 1. This is not necessary to be written. It's understood. It's understood. What's understood does not have to be written. So then I go minus 4k inside the parentheses. Put it in the parentheses. Then I'm going to do 4k squared divided by k squared. Coefficients are 4 and 1. Nothing is written, so that means it's a 1. What's 4 divided by 1? 4. So you put the 4 right there. Then you go to the variables. What's k squared divided by k squared? Also 1. K squared divided by k squared is not k squared. It's not 0. It's not none of that. Whenever you divide something, whether it's a variable or a number, by itself or by the same exact variable or the same exact number, your quotient will always be 1. It will always be 1. But let me show you something though. If I want to apply the division rule to this, the division rule for exponents, right? Well, before I get to that, if k squared divided by k squared is 1, then that means I end up with 4 times 1, which equals 4. So this will just be 4. So I'm going to say plus 4, right? Now, we might be finished, we might not. But before we continue with that, let me show you something. Let's apply the division rule for exponents here. So let's say that I got my 4, right? Because 4 divided by 1 is 4. And then I'm going to use the division rule for exponents. So I'm going to write k next to the 4, and then I'm going to do 2 minus 2. 2 minus 2, because those were my exponents, right? 2 minus 2 is 0. So now I got 4k to the 0 power. Now, there's another rule of exponents that we refer to as the zero exponent property, or the zero exponent rule, meaning that anytime a term or a variable or a number has an exponent of 0, that term becomes positive 1. So k to the 0 power becomes 1. Common error that I want you to look out for: 4 does not turn into a 1. 4 does not turn into a 1. Only the specific term, variable, or number that has an exponent of 0. 4 has its own exponent. It's not written. That means it's 4 to the 1st power. K has an exponent of 0. So k is the only thing that turns into a 1. just the k, nothing else, just the k. Only k turns into a 1. So this is going to become 4 times 1, which is 4. But notice what happened. We got 4 doing it the other way. We get 4 either way. That's the beauty of math. It's many different ways to do a problem. All right? So just keep that in mind. That's the division rule, right? Which takes us to the 0 exponent rule. But also keep in mind that only the term that specific term that has a 0 exponent will turn into a 1. So this 4 does not turn into a 1. Can I tell you how many times throughout my career of teaching high school math, students want just everything to turn into a 1? What you got to think about is this. This 0 don't got nothing to do with that 4. This 0 is only dealing with this k. It's got nothing to do with that 4. Now, if this 4k was in parentheses and the 0 was outside the parentheses, then everything inside the parentheses would turn into a 1. That would happen. We could do that. That could happen. But as it is now, only the k turns into a 1. So we got 4 times 1, which is 4. All right, so now let's go back over here. Now, when we factor, we want to factor completely, meaning that the expression we end up with cannot be factored any further using the methods that we know. I factored out the GCF and I got this, but that don't mean we're done. We could have more work to do. What you do is you look at this trinomial that's in the parentheses and you ask yourself, can I factor this any further? Now, looking at this, I happen to know we can. Why? Because this is called a perfect trinomial square, or some people call it a perfect square trinomial. I don't know which one is right. I think they both right. You know, they both refer to the same thing. Perfect square trinomial, perfect trinomial square, however you want to call it. Now, whenever you have a perfect square trinomial, or let me say this, how do I know it's a perfect square trinomial? Because for one, it's a trinomial. That's number one. It's got 1, 2, 3 terms. Also, the first term and the last term, first term, last term, first term, last term, first term, last term, are both perfect squares. Any variable that's got an even numbered exponent is a perfect square. 2 is an even number. So k squared is perfect. K to the 4th, k to the 6th, k to the 10th, k to the 100th power, k to the 1000th power. Anytime your exponent is an even number, that specific term is a perfect square. All right? So k squared is a perfect square. 4 is a perfect square because 2 times 2 equals 4. All right? So the first term and the last term are a perfect square. Now, this way it gets a little tricky. Try to listen carefully to what I'm about to say. The middle term. If you take the square root of the first term and the square root of the last term and you multiply them together and then you double that and you get a term equal to the middle term or with the opposite sign, then that means that the whole thing is a perfect square trinomial. Now watch this. I know I said a whole lot just now, but this is k. The square root of this is k rather. The square root of this is 2. Right? If I multiply this by this, I get 2k, right? And then if I double that, I get 4k. Now that's equal to the opposite of this, but that's cool. It doesn't have to be a negative 4k. It could either be a positive 4k or a negative 4k to fit the criteria and pass the test. All right, so that passes the test. All right, so that means that this is a perfect square trinomial. Now, how does that help me? That helps me because now what I can do is this. I can factor this trinomial a certain way. So that means I can do this. Bring the k squared down, write one set of parentheses. That's going to have 2 terms in it. Even though we started out with 3, it's going to get condensed into 2 terms. And what 2 terms go in there? The square root of the first term, the square root of the last term. K and 2. Now, what sign goes between them? Plus sign, minus sign, division sign, multiplication sign. Whatever sign was in front of the middle term. This minus sign is going to come down here. So now I got k minus 2. Oh, I left out one last thing. Outside these parentheses should be an exponent 2. Because it's k squared times the quantity k minus 2 squared. All right? Now, the whole perfect square trinomial thing is a shortcut. It's kind of a shortcut, basically. Because another way to look at this trinomial is it's a quadratic trinomial, right? So, and our lead coefficient in here is a positive 1. So another way to factor this would be to look for factors of 4 that add up to -4. And we would do this. Bring the k squared down again. Write 2 sets of parentheses. Take the square root of k squared, which is just k. Put the k right there and the k right here. And again, if this seems like a lot, don't worry about it. Don't get discouraged. You got to practice these. You got to do a lot of these problems, right? Don't expect to have this fully understood after one problem, right? You got to do a bunch of these until the steps start to sink in. And then you'll get into the rhythm of it. You'll get into the rhythm of it, I promise you. But you got to do the practice. If you don't practice, you'll never get it. I promise you that too. So the k squared breaks down into k and k. Now, what are the 2 factors of 4 that also add up to -4? They are -2 and -2. Because -2 times -2 is +4. And -2 plus -2 is also -4. So that means you put those in here. You do the -2 right here and the -2 right there. So now we got k squared times the quantity k minus 2 times the quantity k minus 2. Now notice how this is really the same thing as that. Because isn't this just like a shorter version of this? Because k minus 2 times k minus 2 is the same thing as saying k minus 2 to the second power. Just like this, right? Just like 3 to the second power is the same thing as saying 3 times 3. 3 to the second is the same thing as saying 3 times 3. They're the same thing. All right? So this is the, you can either say this is the final answer, or you can say this is the final answer. Either way, we good. But notice what happened here. We had to do more than one type of factoring. First, we had to factor out a GCF. That's one method of factoring. Then we had to factor this trinomial either as a perfect square trinomial, or we had to break it down using what some people will call the reverse FOIL method, right? But that'll happen too. A lot of times you'll have to do multiple methods of factoring in order to completely factor an expression, because this is the original expression. If you had only factored out the GCF and left it like this would be wrong, right? Because with factoring, it's all or nothing. If it's not factored completely, then it's not factored. Sometimes you got to do 3 types of factoring, or factor in 3 steps. That happens. I've seen it. So this is the final answer, or this is equivalent. So either of these is the final answer. All right. So like I said, though, there's a lot to this. There's a lot of detail. There's a lot of nuance, and you got to practice. There's no way around it. But I'm telling you, once you practice, you'll develop a rhythm. You'll memorize the steps. The steps will start to come naturally. You'll see these problems on a board in class somewhere. You'll see these problems on paper or in a textbook or on a computer screen or your laptop or wherever. And automatically, you'll just start to just know what to do. It's like playing a video game. When you see certain things in a video game, you know what's about to happen because you played the game so much. So you know what to expect. The same thing is going to happen with these. I'm telling you, this is how it's neurological. This is how our brain reacts to things. I'm trying to tell you. So listen, go get some practice on these types of problems. Ask your teacher, ask your professor, ask whoever. Look in your textbook, do whatever you got to do. Go get some practice. Use this video as a guide, and I'll catch up with you on the next video. Peace.